Okay, hello. So let's continue with the next part of the topic. Here today we are going to discuss about electronic configuration. Okay, in this we will discuss about energy level, and we will talk about subcells and orbitals. Okay, so before going into the detail of this topic, so let's talk about what is energy level. So as you have seen that there is a nucleus in an atom and there is shells outside, right, in which electrons they keep on revolving, right. This is called electron shell, right. Now when it comes to what is electronic configuration, it means we are going to see how the electrons are arranged in an atom. That's called electronic configuration. So in one line you can say the arrangement of electron in an atom. That's called electronic configuration. So electrons are arranged where they are arranged. So they are found in these shells, right? Also called electron shells, right? So arrangement is always found in the shells. This electron shell is also called principal energy level, right? Or sometimes also called principal quantum cell, quantum shell. Fine. Now, what is so you can see these cells, these are the electron shells where the electrons are present. So we have a term here called principal quantum number. What is this? Principal quantum number, which is written as n, right? So n, this principal quantum number are used to number the energy level or quantum shells. This is also called quantum shell. Fine. So what is the importance of this? This is used to number the energy level, right? So if quantum number is less, let's say lower the quantum number, right? That means the shell is closer to nucleus. The closer the shell to the nucleus, right? And if quantum number is higher, higher the quantum number means it's far from the nucleus. The greater the energy of electron within that shell. So they are far from nucleus. And as you know, if let's say electron is here and one electron is here, right? So this is more stable. This is unstable. this electron is unstable. Now there's a reason why it is unstable, because it is far from the nucleus, right? So the electronic force, or you can say the nuclear force, is less here, but here it is more in this case. So that's the reason you will find that electrons are tightly held when it is near to the nucleus, right? So let's talk about how we can um, give the number of electrons, how many electrons they hold. So each principal quantum number has a fixed number of electrons, and this can also be found with the 2n square formula. What is n here? N is number of shell, right? So let's say if n is equal to 1, how many electron it will accommodate? 2 into 1 square, that means 2 electrons in the first cell. So I can say here, this is the nucleus, this is the first cell. So n is equal to 1, they will accommodate 2 electron, right? Let's talk about n number 2. So if n is equal to 2, this shell will accommodate 8 electrons, right? So this will go to 8 electrons. What about the third shell and the fourth cell? Let's see. If n is equal to 3, it will be 2 into 3 square, 18 electrons. So the third shell will accommodate 18 electrons. What about the fourth cell? It's 2 into 4 square, means 32 electron, right? So this will accommodate 32 electron. So there is a pattern here, the mathematical relationship which you can see between the electrons and the number of cell is given by this formula, 2n square. So these are the example you can find out the number of electrons accommodated by the shell in the things. Now, still, we have not got the exact location of the electrons. We have got how many number of electrons a shell will accommodate, right? But now still we have a further concept left. So next is we have got the area of the electrons where we can find, but we have not got the exact house yet. So the next concept is subcells. Right? So principal quantum shell are further splitted into subcells. So let's say there are, so I can say the first point that the principal quantum shell are split into subcells. And when we say subcells, we have four types of subcells, right? S, P, D, and F, right? So let's talk about how many subcells are there in the first cell. So let's take an example. This is the first cell, right? N equal to 1. So there is only two electrons can be accommodated as we have seen here. So there is only one S. And S have how many electrons? Two electrons. Now the next shell. Next cell have total 8, right? So we have, so S accommodate 2 electron, P accommodate 6 electrons, D accommodate 10 electrons, and F accommodate 14 electrons. This you have to remember, right? So as the first cell have maximum accommodation of 2 electron as we have got here, right? So the two electron is actually going where? In which subcell? S subcells. In case of N, there is total electron is 8, right? So 2 will go in S, and the rest electron, the P, will go in this. So 2 will go here, 2 will go here, 2 will go here. So total 6, right? So total 6 plus 2, 8. Now the next, when N is 3, we have S in which 2 will go, P in which 6 will go, D in which 10 will go, right? There is one, two, three, four, 5. So in each two electrons will go. So total is 18. If you can count, total we are getting 18 electrons here, getting 8 electrons here, and we're getting 2 electrons here, right? So in the fourth subcell, which is n is equal to 4, S we have 2, P we have 6, D we have 10, and F we have actually 14, right? And if you add all that, you'll get 32 electrons. This is how the subcells are arranged. But the most important concept is the order of subcells overlap for the higher principal quantum shell. You will find that energy of the electrons in the subcells increases in order to, this is S have least, then P, then D, and then F, something like that. This is the uh, energy of the electrons increases in an energy of the electron in subcell increases in order of, so S least energy, and this have maximum energy, right? So least stable, this is more stable. Why it is more stable? Because it is near to the nucleus, right? And if you have to fill the electrons, right? So there's a concept. If you want to fill the electrons, so the first the electrons will go in, uh, let's say first it will go in 1s, then the electron will go into 2s, then after 2s electron will go in 2p. This is n equal to 1, this is n equal to 2, then after 2p it will go to 3s, from 3s it will go to 3p, from 3p it will go to 4s, from 4s again it will go to 3d, and from 3d it will goes to 4p, and in this way it will keep on going, right? So this is how the electrons are going. So let's say if you have to write electronic configuration, before that let's discuss about orbitals in the next lesson. Till now we will, in the next lesson we will discuss orbitals and we'll do the electronic configuration. So far we have understood what is energy level, what is subcells, and how the electrons will go. This is the flow of electrons, right? Let me write here. Now this is flow of electrons during electronic configuration. So when we are going to do the actual electronic configuration, you will find that we are following this order. We'll come back to this again in the next lesson.